Hi, and welcome back to Network Programmability Basics. My name is Hank Preston. I'm a developer evangelist with Cisco DevNet, and today we're going to get back into Cisco DNA Center Platform's APIs with a look at how we can explore the apps and tools with Cisco DNA Center using those APIs. Now, this video is, of course, part of the Network Controllers module with Network Programmability Basics. We already introduced Cisco DNA Center's platform APIs, as well as the east, west, and southbound integration options in a previous video. As always, if you want to follow along with the examples that we're going through, everything is available up on GitHub in github.com/Cisco DevNet/netprog_basics. Every lab includes a README explaining how you can get your workstation set up to follow along with these exercises. And if you don't have access to a Cisco DNA Center appliance, never fear. Cisco DevNet Sandbox has both always on as well as reservable instances that you can take advantage of right now. Now, in today's video, we're going to start out with a quick review of Cisco DNA Center's apps and tools, as well as how we can get Postman set up to take advantage of those REST APIs. From there, we're going to look at how we can get to know our network using the APIs available, and then finally how we can find our way across the network, or more specifically, how our network traffic goes across our network using the Path Trace API. So in a review, right? Cisco DNA Center, it comes with a series of applications that you can use across your network. You can design, manage policy, provision the infrastructure in your network, as well as look at how well the network is operating with the assurance application. Cisco DNA Center Platform is where we provide the programmatic capabilities to Cisco DNA Center. And these include northbound REST APIs, east and west integration options, as well as a southbound SDK to add third-party devices to Cisco DNA Center. In addition to the application are a series of tools inside of Cisco DNA Center you can use to work with your network. You can discover and manage the inventory, take a look at the topology, build templates or send commands off, look at the telemetry data, a whole bunch of great capabilities across your infrastructure available inside of Cisco DNA Center, as well as through the API catalog that comes with Cisco DNA Center Platform. You'll find inside the API catalog, we break things down on categories such as Know Your Network or operational tools. Pick out a specific API you're interested in, and you can see all the information about that, including whether it's a GET, POST, or DELETE request, what to send as part of your request body, or what to expect from the response body as it comes through. Now, as with all REST APIs, I recommend you try out Postman as your entry point to using those. Postman is a simple but very powerful REST API client that allows us to test those APIs in a GUI, store them into collections, set up environments so that we can target different endpoints, multiple Cisco DNA Center appliances, even auto-generate code from those APIs that we can take advantage of. Now, the first step with Postman is to set up the environment for Cisco DNA Center. And you'll do this by creating new variables for the DNA Center IP address or fully qualified domain name, username, password, maybe even the port in case you're running on a non-standard port. Those variables are then usable inside of URI requests or header values or authorization information, all sorts of places. Now, with the environment set up, our first step with Cisco DNA Center, like many APIs, is to authenticate. And we do that using the authentication API request. We'll send our post off to DNA System API v1 auth token. Whew, that's a mouthful. That post request will include the authorization information in a basic auth format. The response body from our post request will include a token value. That token value is used in all subsequent API requests inside of a header of XAuth token. Now, from a convenience factor, we want to take that authentication token that comes back and create a new environment variable. And Postman makes that very easy by using the tests capability built into the Postman client. Now, with that review under the way, let's go through and actually see how we can get to know our network using the APIs available in Cisco DNA Center. What we're after here is to actually unlock the information database that's contained inside of Cisco DNA Center through these APIs. The Know Your Network category has options for sites, networks, devices, and clients. Everything you might want to know. Now, from a network devices perspective, we're going to be interested in the Network Device API. Now, we're going to send our request off to DNA, Intent, API v1, network-device. Now, that API will retrieve all network devices in our environment through its GET request. Now we'll get the inventory details. We'll see the type of device it is, its management IP address, software version, the family it's a member of, all that detail that's there. Now you may find that you don't need every network device every time you make a request. So we can actually use this same API to search for and filter down the returned body by providing a series of request query parameters. Now the API catalog will give you all of the details on this, and I've got an example of it here on the slide. Now request query parameters are part of URIs. They go after the end of the URI, so we get a question mark to indicate we're moving into those query parameters, and then we provide the parameter equals its value. So for example, hostname equals switch1 to search for a particular network device with a hostname. We can also search based on families, MAC addresses, management IP address, many different properties of those devices. Now you can include more than one request query parameter by just separating them with a little AND symbol as it goes through. Now as you get that retrieve the details back, whether these are network devices or clients or sites, every object in Cisco DNA Center includes an ID field. Now these ID fields are unique identifiers that are inside of Cisco DNA Center itself. It also allows Cisco DNA Center to build relationships between different types of objects. For example, here in our slide, we see an ID field at the bottom. That's the ID for this very specific 3504 wireless LAN controller. Right above that, we see a location field. The value of that location is actually the unique identifier for a network location. This allows us to know where this specific wireless LAN controller lives across our different environments. And you'll see this same relationship of different IDs used across objects to build these relationships as they go through. Now let's say you want to retrieve details about just one network device. If you have that device's ID field, you simply append that to the end of the Network Device API request. That'll then limit the returned results to just that request. In this example, we've pulled back details about a very specific Catalyst 9300 switch by providing its ID field. Now, network devices have interfaces, so let's look at how we can find details about those interfaces using the APIs. Now, there's an interface list API that we can take advantage of, and this will retrieve all of the interfaces that come back or that are stored inside of Cisco DNA Center across all of the network devices. Now this typically is far more information than we're actually after in one request as it goes through. In fact, if your network's large enough, you may not actually get all of the details back at once. As we paginate, we limit the number of interfaces or number of objects returned from an API call. So what you want to do is narrow the list of interfaces available. So taking a look at the API catalog, we can find that there are a variety of different interface APIs available to us. We can search for IP-enabled interfaces by providing a known IP address. Or we can actually filter down to the interfaces on a specific network device, which is often what I'm actually interested in. I know the device, now I just want to see the interface information for that device. Or if I'm working in a routing protocol perspective, we have APIs for OSPF or ISIS-enabled interfaces, all available inside the API catalog. Now enough slides for a bit. Let's see some of this in action with a demonstration. So here we'll start out by I've logged into one of the DevNet Sandbox Cisco DNA Center appliances, and if I scroll down through the dashboard, we see our applications listed, design, policy, and so on. Right here's platform, and we'll jump into the API catalog. Inside the API catalog, I can expand out Know Your Network and devices. Now there are a lot of device APIs, so let's go ahead and actually use our search box here for device to filter out the APIs for interface and other ones. Here's the API I'm interested in, Get Device List. I'll go ahead and select this to explore this API. We can see it's a GET API, and the full URL is listed here. And here at the end, we've got DNA intent API v1 network device. We can see those request query parameters I mentioned. We could filter down by specific host name or management IP address, locations, families, types, and so on. Down closer to the bottom is where we'll get the information about this possible response codes. 200s generally are okay, 400s are, again, we the client made some mistake, or 500s, some problem on the server side. Below that is where we'll get into the models. Here we can see the response model that comes back. We can see the model itself, but I'm a big fan at looking at the schema view. This shows me what we can expect to come back. We can see it's going to be a JSON object with a response key, and that'll be a list of individual devices with a series of different characteristics that we'll get back. Now from here, I'm going to jump over to Postman, and we'll see what these look like in live action. Here we can see I've got Postman open. If I take a look at the environment, I am set up here with my Cisco DNAC2.cisco.com, one of the always-on sandboxes, as well as the credentials that we're using. Now the first step we need to do is go ahead and log in. So I'll grab out of my collection the login request. DNA system API v1 auth and token. And then we provide the authorization information in the basic auth type. If I check the show password, we can see we're pulling those in from the environment variables. Go ahead and send this away. In my response body, we can see the token came back. Now that token value got updated inside of my environment variable here to take advantage of this new token that came through. With that done, I can go ahead and send my network device list request off. DNA intent API v1 network device. We'll send this away, and I get back my list of all the network devices. Here's that Cisco 3504 wireless LAN controller we've seen in some of the slides so far. And if I scroll down through, we'll see that there are other devices as well. Here's a 9300 switch. Here's another 9300 switch. And a 38, looks like specifically a 38, I think 50 stackable switch is also part of our topology. Yep, there we go, 3850 24P. So we've now been able to retrieve all of those network devices that are out there. Now one of the things I do have inside of this API request here is this tests. And what I'm saying is go ahead and grab the, we're going to create a new network or a new environment variable called network device ID by pulling out the ID value from the first returned device here. Response 0 will be the first object that comes back. In this case, it's this 3504 wireless LAN controller. What that did is created me a new environment variable here for network device ID, and this here is the value for that wireless LAN controller. The reason I did that is so that I could use that in subsequent requests. For example, this network device details request, we can see that we've got our variable here for network device ID. If I hover over this, we can see the current value that's coming through. Now if I send this one along, this again is a network device request, or network device API, but now instead of getting a whole series of every device, we just return the details about this one device. We end with just that single device that came through. Now we also talked about the interfaces API, so let's take a look at the interface list. As I mentioned, this is going to give us back a lot of data because it's going to be information across every single interface from every single device that's out there. So this would be far more data than we're actually interested in. Now if we take advantage of that network device ID, we can actually search for interfaces by a device ID. Here we can see our URL is interface and then network device, and we give it the network device ID, providing us the ability to hone in on interfaces from a specific network device. Send this off, and now we'll be limited to the responses, just the interfaces from that specific wireless LAN controller. So here we can see Gigabit Ethernet 03, we can see Gigabit Ethernet 04, and then some of the virtual interfaces that come through, all of the interfaces that are part of this particular network device that go through. All right, now that we've seen some of the specific Know Your Network APIs in action, let's actually take a look at an API that gives us access to a more sophisticated capability of Cisco DNA Center, specifically the Path Trace API. Now, Path Trace is part of the assurance application from Cisco DNA Center, and you can get access to it through the GUI as part of the client 360 view. You'll find Path Trace listed there in the list, and when you fire off a Path Trace, Cisco DNA Center takes a look at all of the traffic from the source to destination, and then shows you a graphical representation of how that traffic flows across your network, both wired and wireless, and highlighting things like CAPWAP tunnels that might be in the way. Now, what we want to do is get that same data, but do it through the APIs. Now, we'll find this inside of the operational tools section of the API catalog, and you'll notice that we've got flow analysis is in many of the API call URIs. Path trace and flow analysis are synonymous in this use case. Now, we're going to have three specific types of APIs we're going to focus in on. A post request that will allow us to start a flow analysis or path trace. A GET request to retrieve the details about that flow analysis or path trace. And then finally, a delete request that will let us remove that from the system database. We start out with starting a new trace. This again is a post request to DNA intent API v1 flow-analysis. Now, it is important to recognize that this is one of the APIs included in Cisco DNA Center platform that does require administrative access. This means if you're experimenting with one of the DevNet sandbox always on Cisco DNA Center appliances, you won't be able to use this API. But if you switch to one of our reservable sandboxes, you're given admin access, and you can experiment with this API. Now, we use a post request to initiate a flow analysis. Now, a flow analysis or path trace can take a while to complete across the environment. This is because there could be several different devices in that flow. And so what we get back in our response are not the results, but rather a flow analysis ID field that we use to get the results and work with this particular path trace operation. If we see this in action, once again, we're posting off to DNA intent API v1 flow analysis. And in our example, we're doing a very simple path trace, just providing a source and destination IP address. And we can see that flow analysis IP that's returned as it comes through. Now, using the flow analysis ID, we can then send a GET request to retrieve details about this path trace. We simply append the flow analysis ID to the end of the same URI we used to create the flow analysis, but in this case, again, it's a GET request and not a post. Now, once the flow analysis completes, the status will switch to completed, and you'll get results back hop by hop for every device and every interface along the path between the source and destination. Once you've processed that, you can clean up by deleting the results of that path trace using the delete API. The same URI that we retrieved information, but now rather than getting information, we're going to delete this flow analysis and allow us to clean up after ourselves. All right, in summary, we've gone through quite a bit at how we can use the APIs from Cisco DNA Center platform to interact with the applications and tools that are provided. We saw we could get to know our network and dive into the network devices and interfaces, and even how we can take advantage of applications like path trace that is part of assurance through those APIs inside of our own scripts and applications. Now, as always, make sure to complete the entire Network Programmability Basics video course. We have plenty of other videos across a variety of topics, from programming fundamentals all the way to net DevOps options that are out there. All of the exercises and code examples are included up on GitHub, and be sure to join DevNet and access the large library of learning labs as well as sandboxes to get your hands directly into this infrastructure and experimenting. Now, if you have questions or just want to stay in touch, reach out to me. You can find me at hapresto@cisco.com, on email or WebEx Teams, and I'm up on Twitter at hfpreston. And be sure to follow Cisco DevNet on all the social medias at Cisco DevNet. Well, thank you so much for joining me for this video in the Network Programmability Basics. I look forward to seeing you on our next video.